Okay, everybody, welcome to the SolidWorks assembly animation presentation done by David Israel of Hawk Ridge Systems. He's our reseller for SolidWorks. And so without any further ado, I'm just going to let him jump right into it. Sorry about the delay getting started.
All right. How you doing, everybody? Thanks for having me in. So today we're going to be talking about SolidWorks assembly animations and a couple of tools that are available outside of an animation, just kind of working with an assembly and trying to detect any collisions, looking at how components are interacting with one another. So this is just sort of an overview of the entire SolidWorks software suite. I'd like to bring this to people's attention because SolidWorks has been adding products quite a bit in the last few years. And a lot of people don't realize how extensive the product portfolio is now. We're going to be focusing today on just the mechanical design portion of SolidWorks. But you can see there are a lot of tools that are available for electrical design, analysis, managing, manufacturing, and publishing. So this is a basic agenda of what I'm going to be covering today. We'll start with taking a look at collision detection. We'll look at physical dynamics. Something called a mate controller, which was introduced just a couple years ago in 2016. And then we'll take a look at some motion studies and how you can set those up for creating animations in SolidWorks. So collision detection is a tool that's available inside of the move component command. And this is going to allow you to visualize any collisions that are occurring between components in an assembly when you move or rotate something around. You can look at either the entire assembly or you can just specifically have it focus on a selected group of components. And you can have it find collisions just for those selected components or all the components that are moving as a result of mates to the selected component. So as an example, we'll take a look at this assembly here, and I'm going to activate a different display state just so that we can take a look inside of the assembly. And you can see there are several components here. And what I want to do is just verify that I'm getting full range of motion out of this assembly as I move it. So what I'll do, I'm going to activate the move component command. And inside move component in the property manager over on the left, I have an option for collision detection. So I'm going to turn that on, and like I said, you can check either between all components or just specific components. If you select these components, a selection field opens and I can choose which components I want. So I'm going to choose all components, and I'm just going to choose dragged part only. So this will isolate it just to the part that I'm dragging. It's going to look for any collisions with other neighboring parts. And there's some options as well for whether you want it to stop at collision. And then down at the bottom, there's some other advanced options as well. Things like highlighting faces, and it can play a sound when it detects a collision. So what I'll do is just you start clicking on a face and dragging that component. And so you can see as it collides, we get a sound, and we also see the faces here are highlighting. So obviously there's some collision situation here, and I'm not able to move the assembly through the full range of motion as I would like. So what I can do is I can then exit the move component command, and I can make a quick change to the model. Just go in here, edit the part. And let's say for this pocket, I'm going to change the angle here. Instead of 90 degrees, I'll expand it to 120 degrees. Exit out of edit component. And we'll go back into move component, take another look at collision detection, and we'll see what the results were for that change. So now as I drag the part, you can see we don't have a collision. I'm able to move the assembly through its full range of motion. So I was able to resolve that issue by using the collision detection tool. Yeah, have a question?
You select these components, do you need both colliding components selected or just one is enough?
I believe just the one component is enough. Go back and edit part. I'll do resume drag. Well, yeah, so you do need to select multiple components.
David, sorry to interrupt you, but we can't see the, I can see it on my screen, but we can't really see the type.
Okay.
Toolbar. Your screen a little smaller or something.
Alrighty.
Can you select an assembly in that dialog for these components?
Yeah. You can select assemblies or components.
Yeah, okay. No, I can see it.
Sure.
You have to be able to drive that component, that assembly level. So like for instance, if I have if I
Yeah.
bring a gimbal into a larger assembly, can I move components of the gimbal at the higher level? Or do I have to have access?
You so you'd have to make that subassembly flexible in order to do that. Can you guys see okay? Should I try to make things bigger here, or things look like they're all right? Okay. All right, so let's move on to the next tool. And we'll take a look at physical dynamics. So this is an interesting tool. Allows you to visualize the movement of assembly components in a realistic way just by dragging things around. Anytime a component that you're dragging touches something else, it's going to apply a force, a virtual force onto that part that it's touching, and it will move the component that it's touching in a realistic way. So this is going to be most effective on assemblies that have a small number of allowable degrees of freedom. So what's recommended is you should apply all of the appropriate mates in the assembly first before you run physical dynamics. So let's take a quick look here. Add another example here. So it's got this little Geneva mechanism. And so as this disc rotates, the pin is going to move this green wheel. So as you can see, as I'm moving it right now, there's no interaction between the two wheels. The purple pin is just passing directly through the green disc. So one of the other things that we can just take a look at for curiosity's sake, we go back to collision detection, we can kind of see the same thing that we saw in the previous example, where if I move this part around, so, it's detecting that, yes, it comes to a collision point, and we get the same response we saw before, the sound and the faces highlight. So the physical dynamics is also inside the move component tool. It's just the next radio button down. And you get the same sort of options that we had with collision detection, checking between all components or specific components. And what I can do now, as I drag this, you can see that the pin is applying a force, a virtual force onto this green wheel, so that as I'm spinning one, it's driving the other in a realistic way as it would in real life if we had these parts actually assembled together. So this, it can give you a realistic understanding of how your parts are interacting with one another But of course, this is all just manually dragging things around. So what we're going to take a look at next is the ability to do something similar to this, but in a more automated way where the software would be moving components for you. And then you could actually save that out as like a video file if you wanted to share it with other people. But before we get over to animations, let's take a quick look at the mate controller, which is another utility that you can use to animate or move your components around, move an assembly into various positions. So there are specific mates that you can manipulate with the mate controller. The ones that are listed down here: angle, distance, limit distance, path mate, slot, and width. And what you'll do is you'll add these into the mate controller, and then you can vary the dimensions that define those mates, define the angle, the distance, and so on. And you can specify various positions for your assembly, and then you can have the mate controller animate through, interpolating from one position to the next. So let me jump back over to SolidWorks here. And open up another example. So I have this robotic arm assembly. And to create a mate controller feature, you can go to the Insert drop-down menu and go to Mate Controller. And typically what you probably want to do to start with is just push this button to say Collect All Supported Mates. So that's going to bring in, like I showed before, the angle mates, the distance mates, and so forth that are supported for the mate controller. In this example, these mates have been renamed to a name that makes them more easily identifiable. And then what you can do is you can either modify the dimensions for those mates, for the angles and distances, just here in the Property Manager, or you can do it over in the graphics area. We'll take a look at modifying them here first. So to start with, we just have this position 1. And what I'll do is just kind of move some of these around to a different angle. Maybe something like that. And now I'll add a new position where we are now. You can name it whatever you want. If you want to have a descriptive name for it, I'm just going to leave it at position 2. And maybe now I'll move some other items around. Move this down a little bit, something like that. Maybe twist this around and something more like that. Add another position there. And then maybe now we want to have the gripper open up in this position. So add another one here. And then let's say finally we want it to go back to a home position. So I can just click on the position 1 to have it return here and say I want to add this as a final position also. And so now it's created these 5 different positions. If I go down to the bottom, there's this button to calculate animation. And so you can see it's going to interpolate between the different positions that I had created. And so there's some additional functionality in here. For example, let's say I don't like this position. I want to modify it a little bit. Like I said before, you can change things from the graphics area. So to do that, you have to push the little lock icon, little lock button in the Property Manager, and that'll allow you to then modify directly from the graphics area. So let's say I want to just adjust it a little bit. It's not exactly where I want it to be. I don't have to create a new position like you saw me doing before, but instead I can push this button to say update position. So that will keep it at the same name, the same position that I created before. It's just going to update the dimensions for the angles and so on for the mates. And another thing that you can do after you've created your animation using the mate controller is you can save it out as a video file. So down at the bottom here, there's a little button, save the animation as AVI. Or there's a couple of other options as well, bitmap or series of targas. And you can specify image size and aspect ratio and so forth. And then the other thing that you can do, once you've created that mate controller, set up your positions, you can actually import that into a motion study. So we're going to get into motion studies in a minute, but for now we'll take a look at this functionality of adding mate controller into a motion study. So you can do that by activating the animation wizard. And animation wizard I'll get into a little bit more in a minute, but for now you can see mate controller is one of the choices down at the bottom for what I want to import into this motion study. And I'll click next. And I have two mate controllers that have been defined in this assembly, so I choose which one I want. And then you can choose the import type. We'll get into this a little bit more later. For now, I'm just going to click next. You can specify the start time and the duration. Click finish. And now we have an animation that's been imported here into the motion study. This was from the mate controller that I specified. So the nice thing here, there's a lot more functionality that I can access inside of a motion study if I wanted to alter different things like the orientation or appearances of components. Or if I wanted to, add some action before this or after this or something like that. Any questions on the mate controller? Yeah.
Well, with that, can I define a point? Say if I want to do that motion study or whichever, and if I put like a canister in a particular location, can I bridge those two together if I constrain the height to say that that arm can only go and this position of this can is right here.
Yeah, so you can do a limit to the movement if you do a limit angle mate or a limit distance mate. That would be, defining it before you got into the mate controller, but when you're actually defining your mate, so that would be under advanced mates. And then you would define here, some angular distance between objects, and you specify your maximum and minimum. As far as picking up an object, I guess you could define like a distance mate between the gripper and the object, and you could, tell it that you're going from certain maximum distance to a zero distance as you bring it onto the canister. So you could set it up something like that. Yeah.
Can you do a collision check during a mate control move?
I don't believe so. Do you know? Can you do that?
Method. One was free drag. Was there another?
I don't believe so. I think
The free drag at the top.
They're
Are there
just-
other options under there?
yeah, these are just specifying
Okay.
along an XYZ or something like that. Yeah, I don't think you can access that mate controller in the collision detection. One of the things you can do inside of a motion analysis. So if you brought that into a motion study, and then you turn on motion analysis, you can check interferences at different frames in the motion study. So, I mean, you could see the point when they started to interfere would be the collision. I think that's probably the closest you could get to that. Any other questions? Yeah.
Just historically, I've found limit needs to be break from flip points. Angles also flip points. Comment on what I'm doing wrong.
Yeah, I think it's pretty universal. It's yeah, it's just something that I think SolidWorks has kind of struggled with. There was an improvement last couple of years. I think maybe it was in 2015 in regard to angle mates, which is that now you can define a reference for the angle, which should prevent angle mates from flipping around in different orientations. But I don't think there's really been any change to like distance mates or limit mates. I think those, well, I mean, they've done a little bit of improvement just to the way that the mate solver works. So it should function more predictably now than what you've experienced a couple of years ago. Because I think SolidWorks is aware that it is a situation that a lot of people do run into.
David, just one thing on that I've noticed in the motion study, if you do a gear mate, those can also reverse on you. But when you're actually in the motion study, there's two choices. There's the animation and there's the
Basic motion.
basic motion.
Yeah.
It behaves better in basic motion. Just that general animation one, it always will flip on. And then when I turned it to the basic motion, problem decreased. It didn't go away, but I ran into it less. That when you do that, you pull a license of premium because it's using SIN, right?
Well, not for the basic motion, but for motion analysis.
Basic motion is free for everybody.
Yeah.
But yeah, that's what I've done is always put that on basic motion instead of the animation. You have better results.
Yeah. I think we're going to get into that right now. So yeah, here we go. Good segue. So with motion studies, yeah, there are three modes: animation, basic motion, and motion analysis. So animation, motion is defined by interpolating between positions. Just like we saw with the mate controller, it's really just looking at, position 1, 2, 3, and so on, and it's just going to do a linear interpolation between each position. Doesn't account for mass or gravity or anything like that. It's really just strictly animating some kind of change. Basic motion will approximate the effects of motors, springs, and contact. So it's going to give you a more realistic simulation of actual movement than an animation study would. And it does account for mass and gravity. But it is still an approximation. So it will run fairly quickly because it's not doing a full, solution, whereas motion analysis will do a complete solution. So motion analysis will tend to be slower than a basic motion study, but basic motion is a good approximation. So if you don't really care about, like the complete physical effects and you're not interested in like reaction forces or graphing anything, getting any kind of like result plots out of it, then basic motion is a good option. But if you do need those more, analysis level tools, then motion analysis is what you would need to use. So this will be a fully, completely accurate simulation. We'll analyze the effect of all motion elements that you'll have access to. It accounts for mass, gravity, and material properties as well. And like I said, you can plot the results for further analysis. So motion analysis is only available with a license of SolidWorks Premium. And so you'd have to go to the add-ins and you would have to turn on SolidWorks Motion to get access to motion analysis. But if you don't need that, and we're just going to focus today on animation and basic motions, then any license of SolidWorks will be able to get you access to animation and basic motion. And so you can animate the following things in a motion study: component position, component properties like hide and show, display mode appearance, effects of motor driving an assembly, effects of a distance or an angle mate, kind of like what we saw with the mate controller, the viewpoint orientation, camera views, light and camera properties. And then these are different techniques that you can use to create animated motion studies. So the animation wizard we just took a look at with the mate controller, but it also has the capability to do rotations and explodes and collapses. You can drag the time bar and move components, and these are all techniques that I'll show you guys in a minute. You can use motors, gravity, or springs to drive the motion, and then you can also do camera-based animations. So let's take a quick look here. And we'll start with this one as an example. So if I want to do some kind of animation to this, let's start by taking a look at the animation wizard. So like I said, this does rotations, explode, collapse. This assembly already has an exploded view in it. And you guys are probably already familiar with the ability to animate the explode and collapse, which you can do just directly here. You don't need a motion study to do this. But you could have it like reciprocate or do a loop, whatever. So you can see the way that the explode steps are configured. And you can save this out as an animation, just like we saw before with the mate controller. You save it as an AVI file. So that's just kind of individual. If you wanted to look at explode or collapse and get a video of that, you don't have to create a motion study. But we'll take a look at a motion study if you wanted to do some additional things like adding operations before or after or changing other characteristics. So take a look at an animation motion study. And just to give you sort of an overall explanation of the interface of a motion study. So obviously you've got the timeline is the largest portion of the motion manager interface. And this is where you're going to be controlling what happens to these components inside the animation. You can see these diamonds at the start of the timeline, and these are referred to as key points. And the key points is sort of a snapshot of what's happening with that component at that instant. So we'll see as I use the animation wizard, what it's actually doing is it's going to be creating key points at different times that correspond with the movement from the explode or from the rotation. And then you have a tree on the left down here, which mimics what you see in the feature manager design tree. Although this is called the motion manager tree. So you can do some operations in the motion manager tree that are independent of the feature manager design tree, such as adding mates. You can have mates that only exist in the motion study that don't actually exist in the model itself, which is a very useful technique. And then you've got this toolbar up at the top of the motion manager interface where you have a few buttons here for activating different commands. So let's go back into the animation wizard and we'll take a quick look at an example here doing a rotate. So I'm going to choose that first radio button and I'll click next. You can choose the axis that you want to rotate around. the number of rotations that you want to do, and then whether you want to do it clockwise or counterclockwise. And then you can specify the duration and the start time. Let's set this for 5 seconds, and then I'll click Finish. So you can see it's added some keys here that correspond to different orientations of the model as it goes from 0 to 5 seconds, which I specified as the duration for that rotate. And these little brown bars, those are just identifying that the mates are all active and they're being solved through the entire length of that animation from 0 to 5 seconds. There's a pretty good explanation of all of the different items that you'll see in the Motion Manager interface if you go into the help. And then you go to Motion Studies, Introduction to Motion Studies. Actually, Motion Manager interface. So here it's got an explanation of just all the terminology that's used for the different elements in the Motion Manager interface. So the timeline, the key points, and it'll show you, this article is especially helpful. It just kind of shows you, the different colors of change bars, like we saw there for the mates. Not really that critical to know the difference in the colors, but if you guys wanted to have a better understanding of exactly what the motion study is doing, so you can take a look at this help article. So now if I calculate this motion study, so it's just going to do what I specified in the animation wizard, which was to rotate around for 1 revolution over 5 seconds. You can also, you can drag the time bar to any point. If I wanted to take a look at a specific time, you can do that as well. So let's take a look. Say, for example, now I wanted to do an explode and collapse after it does the rotation. I can just go right back into the animation wizard. And let's say now I want to do an explode. And now I'll start it at 5 seconds after it does the rotation, and I'll have it complete after 5 seconds here as well. So now this is a little bit more interesting. We can see these change bars that are positioned here between the different key points. So this corresponds to individual parts as they are exploded out. So the first key point will be the initial position, and then the second key point will be the final position. And like I said, with an animation, it's just interpolating between the 2 positions. There are a couple of view commands for viewing the Motion Manager timeline. Up a little bit here so you can see them. So one of them is zoom to fit, and then you also have a zoom in and zoom out. So if I do zoom to fit, you can see it just kind of shrinks the timeline down a little bit, so now we can see all the way to the end of the animation that I had created. And I'll go ahead and calculate it again. So you can see the yellow area of the timeline indicates that that's already been calculated. But the second portion, the explode, that I had just created in the animation wizard hasn't been calculated yet. So I'm going to go ahead and click calculate just for it to calculate the explode steps. So now if we play the entire thing from the start, this is going to go through, do the rotation, and then it's going to do the explode after that. You also have some control over the playback speed. So say I wanted to watch it, double speed. I can set it like that, and then I can see a faster playback. And let's discuss also this orientation and camera views. So, yeah.
So you just thought of the playback speed, is there a way to scale?
Yeah. If this key point at the end of the animation, at the very top of the motion manager tree, if you hold down Alt on the keyboard and then you drag that, it will scale the entire animation.
No way to scale the subset of the animation though?
I don't think so. Yeah, I mean, the only thing that you can get that's sort of close to that is if you wanted to select multiple key points, you can just drag like a window around key points. So if you had, a bunch of items that all ended at 4 seconds and you want it to be 8 seconds, you drag a window and just drag one of them, they'll all go together. That's probably as close as you can get to doing something like that.
That viewer batch came in from a wizard, so you could re-import it with different total time.
Yeah, you can do that too, yeah. And this thing is really finicky. If you guys have worked with it before, it's kind of hard to grab that top of the motion manager to move it. You got to be really precise.
Sorry, one follow-up question on what you suggested. If you do another animation with it, that's overwrite.
I think there's one thing you can do, which is to delete the existing paths, but that'll just delete everything. I think if you overlay, not sure, haven't tried it before. Maybe I'll try it after, I think you guys get the idea. Let's just do a collapse here. I'm going to add this onto the end. So it'll start at 10 seconds, and so there you guys can see that it'll do rotation and then explode and then collapse. So let me just talk about the view keys for a second, then we'll test something out for you. So the blue key points down here are referred to as key points, and these control the position and a couple of other things. If you expand one of these components, you can see it's controlling moving, exploding, and appearances. And just, to be technical, probably unnecessary, but those black diamonds that are next to the orientation item are technically called view keys because they control the view. So you can see that when it does the rotation at the beginning of the animation, that's really just a change in view. It's just changing the orientation of the model as you spin around. But then for the explode and collapse, it's actually moving parts. The orientation is not changing, but the movement of the parts is changing. That makes sense? Just to confuse you guys even more with the difference between view keys and key points. So there's something that confuses a lot of people with the orientation and camera views, which is if I right-click on this, there are a couple of options here. One of them is to disable playback of the view keys. Remember, the view keys are just for the orientation. And then there's also an item which is disable view key creation. So this is how it'll show up by default, which is that the view key creation will be disabled, but the playback of the view keys will not be disabled. So what that means is, let's say, for example, I'm going to turn off disable view key creation. Okay, so it's no longer pushed in. So that means view keys will be created automatically if I change the orientation or the zoom at this point. The time bar is at 8 seconds right now. So you can see if I change by zooming, now it's created a new view key here at 8 seconds. And it's going to interpolate between this point and then zooming out to this point. So if I play it now, you'll see it'll rotate and then it'll zoom out as it's doing the explode. That makes sense? So in order for it to automatically create that, I had to right click and turn off disable view key creation. So if I go back to the setting that it was at before with disable view key creation turned on, so now let's say at 12 seconds, I do another zoom operation. I zoom here. So now you can see it did not create a view key because I had view key creation disabled. Make sense? All right, so then the other thing is to disable the playback of view keys. So if I turn that on, now you can see those black diamonds have changed to gray. So now it won't even play back those view keys at all. So if, like I had set up here, a rotation and then a zoom, it's not going to play those back. If I go ahead and play from the start, you can see it's not rotating, it's not zooming, it's just going to maintain whatever orientation I have right now. It's just going to keep that because it's not playing back any of those view keys. Okay, any questions on that? Okay. What else? Let's test maybe.
David, can I just one thing?
Sure.
A lot of times with the view key creation, if you want to go back to a home spot, you can copy and paste those keys. So if you want to zoom back up the exact same spot, just
Right.
do it the first time and paste it in.
Right. Yeah, so I'm going to turn off disable playback of view keys. So now it will be playing back the view keys. And so like Lars said, if I had zoomed in at 8 seconds here, if I want to zoom back out later, so you can copy and paste keys, not only the view keys, but also the key points for the movement of the components. So let's say I wanted to zoom in and then I wanted to pause there for 2 seconds and I wanted to zoom back out. So I'll right click on this key, copy it, and then I'll right click at 10 seconds and paste it. So this is now the identical orientation between these two keys. That's why there's no change bar, there's no black bar between them. And then let's say I want to go back to this position at the end of the animation. So I'll right click and copy this, and I'll right click and paste it here. So now it is interpolating between those two. So from 10 seconds to 15 seconds, it's going to zoom back in. For the view keys, for the orientation, you don't have to recalculate the study. You can just play it from the start. So here it zooms out, pauses, and then it's going to zoom back in. Make sense? All right. Oh, should have done that.
Possible to animate the modification of a feature? For instance, if I have two things that I want to separate from one another that are connected by a string, I want that string to show up in the animation. How do I make that string longer as one moves away from it?
Yeah, you want to answer it?
Yeah, if you do a top-down part that resolves, right? So as these get apart, the actual,
Where's the top down?
a part that's built in the context of the assembly.
Oh, okay.
Where instead of saying it's this tall, you say it's from this point on this part to this point on this part. When the parts move, the part
Resolve every time.
resolves.
Okay.
When you run through the animation, each frame it will resolve that part against. The part looks like it gets longer when you're done with the animation.
Okay.
So you do springs like that too, is what a lot of people do.
I'll probably find you
Yeah.
this afternoon or get you. Are there features for like ease in, ease out, acceleration instead of just linear?
Yeah, so that's available if you right-click on a key point. I don't know if you guys can see that. So I'm right-clicking here. Down at the bottom is Interpolation Mode. By default, it's going to be linear whenever it creates a key, but you can go in and change it to either snap or ease in, ease out, or both ease in and ease out. Good question. Okay, so let's take a quick look at trying to overwrite what I'd already done with the animation wizard. So I'm not going to check delete all existing paths. Let's do a collapse at 5 seconds when it should have been doing the explode. Actually, let's just completely mess this up. Let's start and explode at 4 seconds and have it go for 4 seconds. And let's see what it does. Yeah, it looks like... Yeah, so yeah, it doesn't get rid of any of the keys. It just adds keys in there. Yeah. Okay, let's take a look at another example. So here, let's move on to basic motion study. So basic motion, like I said, will take into consideration gravity, mass, contact between components. So this assembly, it's just this slide component and the 3 balls on top of it. So they go into a motion study. Just create a new study. So if you need to create a new study, you can right-click on the study tab at the bottom. You can create a new study. You can rename the study, or you can copy the study. I'm going to just create a new one. And so what I'm going to want to do is choose basic motion instead of animation. And so first I need to add gravity because that's the only thing that's going to be driving the motion in this example. There aren't going to be any motors or springs, and I'm just going to let gravity do all the work to move the balls down the slide. So gravity is right here. You can set parameters for the direction just based off of the global coordinate system. And you could specify a different value if you want to. I'm just going to have standard gravity at sea level here by default. Click OK. And then so by default, it just creates the study for 5 seconds. And gravity shows up here in the Motion Manager tree. And what I'll go ahead and do is actually just I'm going to leave this at playing back at quarter speed. And I'll go ahead and calculate the study. Oh, that's good. Let's stop it there. So it's not quite what I was hoping. So gravity did what it's supposed to do, but the balls were not interacting with the slide the way that they're supposed to. So what I forgot to do is add contact. So I'm going to go ahead and create a contact feature. And to do this, actually, I'm going to move this back so the balls are actually on the screen. So here I can just do a window around everything and select them all. Or there's this checkbox here for use contact groups. But what this does, it tells you contact between items in the same group is ignored. So I could do something like this, where the 3 balls are in one group and then the slide is in another group, but this won't take into account any interaction between the balls if they ended up knocking into each other. So to be, perfectly realistic, I probably don't want to do it this way. I would rather do it where everything is in the same group. So click OK, and that creates this solid body contact here in the tree. And I'm going to shorten this down to 2 seconds. And I'll go ahead and calculate. And so now we get the motion that we're expecting. Okay, any questions on this example?
Can you use other things like initial velocity?
I believe you can do that in a motion analysis, but I don't believe there's a way to do that in a basic motion study.
Gravity's got keyframes, so you could reverse gravity.
Let's see. I think you can. All right, fine. Maybe not. No, it doesn't look like you can.
Can you do a copy keyframe thing?
Let's see. No. So,
Probably a good thing.
yeah. But I think you can. I think you can. No, maybe not. Yeah, even for contact 2, you can suppress and unsuppress it, but you can't I don't think you can turn it off in the middle of a study. But you can do things like that with like mates and motors, which we'll take a look at in a minute. Any other questions on this example before I move on? Okay. So let's look at this one here. So there's this little limit mechanism, and as this wheel spins, it's going to hit this component and just kind of make it go back and forth.
Actually, one question on the previous previous one?
Yeah.
Were those balls rolling or sliding?
They're rolling.
Okay, so it's actually affecting the friction movement surfaces.
Yeah. So again, let me create a new study. And I'm going to do basic motion. So just like we saw in the last example, I'm going to have to add contact between these. Add contact. And this time I will use contact groups. So in the first group, I'm going to choose all of these. And in the second group, I'm going to choose the two rollers. And now what I want to do, I want to have the wheel rotating. So there are a few ways that you could do that. If I had, for example, an angle mate that defined the position of that wheel, I could change the angle mate at different times in the animation. Or I could just kind of drag things around, sort of like you saw me do with the explode and collapse on the flashlight. You can just manually move parts around in the graphics area, and that'll create a new key point for motion. But what I'm going to do in this case is I'm going to create a motor, which is going to drive the spinning of the wheel. So with the motor, you can either do rotary or linear, and then you're going to select a location for the motor. I'm just going to pick some reference, just some circular edge on that wheel. And then I want it to spin in the other direction, so I'm going to click this reverse direction. Actually, and then I'm going to define the speed. So set it to 10 RPM. So the rotary motor is now defined here. It's going to be on from 0 seconds to 5 seconds. And let's go ahead and calculate. So for this one, I'm going to disable playback of view keys just so that I can have control of zooming in as it plays the animation. I want to be able to look at it from the angle that I want. So let me go ahead and calculate. So you can see as the wheel turns, it's hitting the two rollers and it's causing that triangular component to go back and forth. In a situation like this, when you have contact, you might experience something where the parts may interfere through each other, or you might get sort of erratic or unpredictable behavior from the parts. So what you can do to correct that is if you go into the motion study properties, there are a couple of things that you can change in here. One of them is frames per second. You may be able to correct that problem just by increasing the number of frames per second. And this is, so motion is actually, it's solving the movement, the mates at every frame. And if you increase the number of frames per second, usually it does, it'll give you a more accurate solution. So it should correct something like that. But if it doesn't, then you can also go in and change either the geometry accuracy or the 3D contact resolution. So the geometry accuracy, what motion's actually doing is it's working off of a tessellated body, tessellated representation of these parts. So if the geometry accuracy is set to low, then the tessellation is going to be pretty coarse. And you might have a situation where the contact isn't really that accurate. So if you increase the geometry accuracy to a higher level, it'll give you finer tessellation, which should give you a better motion animation, a better result. And then the 3D contact resolution is looking at the contact specifically where parts are touching each other. And at a low 3D contact resolution, it's not really going to be able to interpret that contact very accurately. But if you move that up to a higher level, it'll do a better job of recognizing when parts come into contact with each other. So obviously, if you set these to a higher level, it's going to take a little bit longer for it to run the calculation of the motion analysis. These are pretty simple examples, so it runs pretty quickly. But if you have a really large assembly, pretty complicated model, then you might run into a situation where you're waiting for a while for it to calculate. With animation, you only have one option in here, which is just the frames per second. That's the only thing that you can modify in an animation. With a full motion analysis, there are additional settings that you can change as well that get into things like the solver. There's a few different solver types for the motion analysis, and then some other settings in there for just accuracy of things like this. Okay. So with the motor that I've defined here, I could do things like placing a key in the middle here and turning the motor off at this time. So we can calculate and see what happens here. So you can see the wheel slowed down. So like I said before, with a basic motion study, it will take into account mass and gravity, so it does recognize that there's some inertia to that wheel. So it slows as that motor is turned off. You can do other things as well. For example, let's turn it on, but at this time, I can edit the feature, and let's say I want to set it to 0 RPM. So now, and then let's say for the interpolation mode, I'm going to have it ease in. So now that motor is actually defined to be 0 RPM at that key point. So it will stop the wheel from moving at that time. Any questions on any of that? Yeah.
What would an error look like if you were to spin the motor the other way?
Let's take a look. Let me edit the motor. Actually, let me move this back to 0 seconds. And I'll edit this, and we'll go the opposite direction. And we'll see what happens there. So
it doesn't throw an error. It still somehow calculates through.
yeah, in a basic motion study, you might see situations where one of the diamonds, one of the little key points might show up as red. And that sometimes will tell you if it's not able to solve for that key point. In a full motion analysis, it's more common that you might run into a situation where the solver is not able to provide a solution, and it will put an error up on the screen. And for those cases, then you'll have to go into the motion study properties like we saw, and maybe try a different solver or try increasing the frames per second or something like that. But yeah, I'm trying to get it to a situation where doing a pretty good job.
Well, I think basic motion, it won't catch these errors and report it to you.
Yeah, I mean, you won't see like an error message, but like I said, you might see a situation where the movement, like you have bodies that are going through each other, something like that. That's going to be your only indication that something's not working right. Like there, you can see it's.
But it doesn't like mark it with a little blip, like somehow put some notation on there.
Not with basic motion. Yeah. Okay, let's take a look at another example. Let's look at this. So here, got this assembly and have some fasteners in here. So this might be a situation where you want to show some explode steps and you actually want to show like a fastener rotating as it's being disassembled. So let me go ahead and create a motion study. And all right, so to start with, like I said before, there are several different ways that you can have motion with the components. The motor we just took a look at, and this one, what I'm going to do is I'm just going to move by dragging, like I mentioned you could do. So what I need to do in order to drag the fastener out of there is I need to first suppress this mate. There's a mate in there, a coincident mate that's locating the fastener in that hole where it's supposed to be. So just, for demonstration, if you want to see, well, there's not a whole lot to see, but let's say I wanted to move this fastener. So I right click on it, and you can either do move with triad, or I could do the move or rotate component tools to move something. Like we saw, you can do, by delta XYZ or so forth. So let's say I just right click on this and I choose move with triad. So if I try to move it, nothing's happening. So that's what would happen. That's what you'd see if you tried to move something, but there was a mate that was restraining that part in that location. So in order for me to move it, I need to go in and right click on the mate and suppress it. Sorry, what happened is since I had the time bar at 2 seconds, it suppressed the mate at 2 seconds, but it is on at 0 seconds. So let me go ahead and copy this key and paste it here. Then I can delete this one. So now that mate is off or suppressed at the beginning of the motion analysis or the motion study. And let's say now I'm going to move it to 2 seconds, and I want to see that fastener move out. So now I'm going to right click on it and choose move with triad. I'm just going to drag it up, and now you can see that it's moving like I want it to. And so we can see if I expand that, the flathead screw, there's a change bar that's located next to the move item that lets me know that it's moving. I can also add something in here to rotate the fastener at the same time that it's moving out. So I'm going to do a motor in this case. I'm going to choose a rotary motor. I'm just going to select an edge of the fastener. And I'm going to set some value for the speed. And you can change this as well. You don't have to just do constant speed, but you could have it go over a specific distance from a start time to an end time. It's going to rotate through a specific angle. You could have it oscillate back and forth. So there are, or you could even, add some data points, fill out a table for exactly how you want the motor to behave over a certain length of time. So there's a lot of control that you have over defining these motors. But I'm just going to do constant speed. And I'll click OK. So the motor shows up here. And really, to be able to see it properly, I'm going to increase the frames per second. I'll just set it to like 60 frames per second. That'll give us a smoother view of what's happening. So we'll go ahead and calculate that. And if I want to adjust the orientation, so what do I have to do in order to do that? If I want to change this view, obviously the screw's off the screen. So if I just move this down, you guys think that's going to be enough to change orientation?
Depends on the status of the orientation. Disable keyframe.
Yeah, great. Good. So I have disable view key creation turned on. So that means it's not going to recognize the change that I made to the view, even if I recalculate it here, so you can see it's still off the screen. Good. So I need to either enable view key creation, or I can just disable the playback of view keys if I don't want it to be changing the view as we're watching the animation.
You update an individual key, right?
What's that?
You can update an individual key, right?
Yeah. So like now I have it in a position that I would prefer. So there's not a key that exists here. One thing I could do would be right click and say place key. So that's kind of a manual way of creating a key at that time. Yeah, you could always just replace a key if you wanted to change something. Okay, so now if I play it, so it's interpolating from the position that it was in, or the orientation at the beginning, to the orientation that I specified at the end. And just yeah, so you can copy and paste just like we saw before. So you can see as the fastener comes out, you can see it's rotating as it's moving out. So that's another example of a situation that people might want to apply a motion study to demonstrate, assembly steps. So this is a commonly used technique. Any other questions at this point? Yeah.
I just have a comment as someone who's worked with this before. It's for anyone who's helped out with the same mistakes. The position of that gray bar is like where any change you make is going to be applied. So in this example, we want the screw to turn faster. You can't just go ahead as a motor. Now, you drag back to the beginning so it starts in order to do that. And I think even just today, a couple times, that's on. Happens all the time to me. It's just something to really be freakishly aware of.
Right. Yeah, good point. It's a little counterintuitive, but yeah, as you're making a change, so let's say, for example, I want to move the fastener again, or I want to rotate it or something. So if I have my time bar here at 2 seconds and I make a change, it's going to now change the key here at 2 seconds and probably cause it to do something that I didn't want to do. Whereas, let's say what I really want to do is after it moves this out, I want it to rotate the screw or something like that. So I want to move the time bar to 4 seconds first, and then I want to make my change. So here, I'll do move with triad, and let's say I want to rotate it like this. So now you might have noticed it created a new view key here or a key point at 4 seconds. And if I calculate, so you can see it first moves the fastener up and then it rotates. There's no concentric mate. There was just that one mate on that fastener.
When you suppress it, that's only in the motion study, right? You get the model.
Right.
It's not suppressed.
Right. Yeah, the mate is still active in the model itself. It's just in the motion study. Yeah. In the motion study, you're controlling the suppression state of the mates independent of the model. Let's take a look at, well, maybe I'll open up to some questions. That's basically the content that I want to show you guys. There's a lot of other things you can do with motion studies, especially when you get into motion analysis. But maybe, do you guys have any questions? Have you worked with motion studies in the past and you run across something that didn't make sense to you, or you want to see a specific technique or something like that? Yeah.
Are there any tricks with using this with a photorealistic renderer, or is it just kind of...
You can do it. What's that?
Set it to work over the weekend.
Yeah. Yeah, that's probably the best tip. So yeah, with PhotoView 360, if you have that enabled, when you save out the animation, you can specify that you wanted to do a rendered animation, but it can take quite a long time to do that.
It renders every frame.
Yeah.
It's a lot faster if you move to visualize, but it takes a lot better. You higher it. Outside would be a lot faster.
What's visualize?
It's the new program based off of GPU processing. Yeah.
It's not SolidWorks.
It is SolidWorks. They bought out Monkspeed, and they rebranded it as SolidWorks Visualize.
So it actually uses your...
Yep.
Earlier I asked about scaling a section, so I don't expect you to... I mean, yes. But recently I want to reverse, there was things fading away, things coming back, so it's not quite an explode with where it has this sort of built-in pass. I didn't have a way of doing it. Is there a way to take a chunk, maybe copy it, reverse it, speed up? Is there any sort of bulk editing tools like that?
Yeah, there is. Not sure why those are red, but if you, I think you have to grab the start and end key points, and then you can choose reverse path if you right click on it. Yeah, that's gonna reverse it right here. So let's say, oh, whatever. Let's see, first I want to copy these and paste them here. So I could do the same thing. Reverse the path of this, should rotate them back. Yeah.
Is that true for display modes too, like transparency, like reverse display?
I think so. Yeah, I think it's basically the same as just like copying the first key and moving it to the end and copying the second key and putting it at the beginning. I believe so, yeah. But yeah, that brings up some other things you can change, appearance and display style. We didn't really get into, but show an example. So at, I'm going to move this to 2 seconds and I'm going to right click and go to appearance for this component. And let's say I'm going to just change it to a different color. So do like this red color. And then let's say at 4 seconds, I want to change it to something else. Move the time bar first, then right click and go to appearance. And select this one. And again, move the time bar, change the appearance, and choose this one. So you can see as the motion study goes on, the color is changing between the different key points. And it's doing the linear interpolation like we saw. If you wanted to change that, you could have it like do a snap at each one. So then it will just change immediately. So you could have something like this where, you know, just changes color immediately. And you could do the same thing with display style, you know, whether it's shaded or wireframe or something like that. Anybody else have any other questions?
Would you mind, I think that spring's probably supposed to be, but I've never actually done it. But would you mind demonstrating that? I've got one, I built one.
Oh, really? Okay.
So, that's why, yeah, you showed it.
So you can see what I've got here. So the main thing that's going on with this part is you see this little mark right here. It looks like a minus symbol and a greater than symbol. That means it's getting information from an exterior source. In this case, it's actually, when I go in to edit this sketch, this point right here is coincident with the edge of the part. So rather than me specifying how tall the part is in its own file, I'm saying that the assembly, I want the top of this part to always be at the top of this plate, where the bottom of the part is locked to the bottom plate. So the thing is that you're not going to really see much happen as far as in your animation. So all I've done is there's a distance between these two plates that I've set up. This plate goes up, plate goes down. You see that as I'm looking at it, it doesn't look like anything is happening. But if I solve it, you'll see it happen somewhat in real time. Problem is when I play it, it's going to do the same thing where it just bounces up and down. You don't get to actually see the part until you save it out. So I saved this thing out. Here it is. So when you save it out, you see it actually solving each frame. It recalculates where that part is for each frame so that when you ship out your assembly, it looks like the part is growing or shrinking. But yeah,
Can you model, instead of just changing the distance between those plates, can you put a kinematic spring between them so that they behave like a spring? Can you show me how to do that?
No. I don't know if,
I mean, that's one of the options. Like, instead of a motor drive, you could say there's
oh,
two parts that act like they have a spring.
right. And what that does is that will show graphically a little purple thing that looks like a spring, but it's not an actual model.
Right. It's just, sorry. My request for the spring is not related to my previous request about changing a feature. I actually want to understand how you make the thing behave as if it was a spring. Am I not making sense?
No, you are making sense, but that's more.
I also want to know how to do that. There's two separate things.
Okay, so I'll explain that one. You got that one now?
That's fantastic.
All right. The other one is more of a motion study, right? For springs, do you need to go into a motion study to get that sort of?
Yeah.
You want it back?
I'm just looking at that icon above the 10 second. You know, you can grab the motor, you can grab the spring too, right?
Yeah.
Thanks, Alex, for your attention to that.
This. There you go. Let's see, find an example. Let's do this. So let's say you have to do either basic motion or motion analysis. And go ahead and define the spring. So you can either do linear or torsional. Let's take a look at a torsional spring. So you can select something, let's see, first endpoint and axis direction. Yeah, I guess, so an edge will suffice for a rotary spring, torsional spring. And you can just find the spring constant here. And I think that's all you need to set up, really. All right, okay, that requires motion analysis. Let me see. I thought you could do springs in basic motion. Well, let me just turn on motion analysis. Well, that's not working either. Let me see if I have another example.
Does the spring have to be relative to something? Do you put a reference it back to something?
Maybe, let's see. Yeah, could be. Oh, I think I need to specify this. Oh, let's see.
Like an initial condition or something?
Yeah, I think that might be what this free angle is. Yeah. Oh. So there's an example of a torsional spring. So that, yeah, the free angle is kind of like your rest state. So you can do the same thing with a linear spring. Let's see if we can get something here to work. Like from this vertex to, let's say, this vertex. So this is what Lars was talking about. It will show you sort of a representation of a spring, but it's just like a virtual representation. I don't know. You can change the display of it, so the number of coils that you have, the coil diameter, whatever, but it's just the, appearance on the screen. Let's calculate this. Yeah. Anyway, if I should probably increase the frames per second if you really want to see. Yeah. But that's essentially how you'd set up a spring in a motion study. Any other questions? That's the contact that we set up before. Yeah.
So there's no way to show like the effect of like a collision off the steel ball on glass. It doesn't like animate it at all.
No, there's no deformation to the bodies. They're just considered to be rigid bodies. I mean, you could, if you got into the full motion analysis, you can get results from a study like that would show like reaction forces, and then you could import that into a simulation study, and you could see, deformations from that amount of force.
Is there any, I had animated something that someone make it work in some system. Like, is it compatible with any other stuff? Like if I animated something like Maya or something, I can't bring that into SolidWorks.
I don't think so. Lars, do you know of a way to import some animation into a motion study or something like that? I don't think there's a way to do that.
Usually that's also the process where you do.
Yeah.
Use a video editing system for that, just get little snippets from here. Process to get.
Okay, well, if there aren't any other questions, then that just about wraps it up for the content that I wanted to cover. So thank you guys for coming out. I appreciate you taking the time.
They're trying to do the whole thing in one single animation. That's the most important part is like, I gotta rebuild this again. I gotta rebuild this again. Okay. So if you keep it a little tiny. What's up, David?
Hey.
So, man,
Yeah.
sorry I was late.
No problem.
Where the heck is Andrew at?
He was off with another obligation. He said he was going to drop in a little bit late, but this is
Cool, got a
very
pretty
late.
big crowd.
Yeah.
I sent
No, that's
out,
good.
I sent out invitation reminders to each and every individual group of things instead of ours just usually just says all SolidWorks users, which, a lot of people, if they're not here at Rails, are not going to come over here. And they'll usually just live stream
That'd be
it.
so cool if you can send out snippets
Cool.
between each other.
Yeah,
Did they feed
thanks
you?
for,
Or
I'm hungry, but Andrew and I have another meeting at 2:30.
if you want, you can grab a bite real quick. I'll take you over.
Okay, sure.
You got your badge, right?
No.
Lars, get you a badge? No? Okay, Lars. We'll go get you one.
Thanks.
David Israel, right?
Yeah.
They're saved inside. What's that over there? You open it up, you see all the tabs already? Usually it says model, motion setting, you see model and motion setting.
Or you can set that as like a specific length of time. Okay, yeah, then that makes sense.
Yeah, each motion setting can be its own.
Yeah, and then they can break it out.
It's just trying to do it all in one motion study. That's where people get frustrated when they don't want to do it.
Yeah, but then if you skip it, that's perfect. Thank you so much.
Yeah.